Okay, I want to analyze this graph. Hold on for a sec. Okay, I'm going to talk about analyzing the graph of a polynomial function. Here I've got 2x plus 1 times x minus 3 squared. First of all, let's take a look at what our y-intercept would be. If I plug in 0 for x, that'll be 0, so it'll be 1 times 0 minus 3, negative 3 squared, which will be, it's like 9. This is negative 3 squared, 9 times 1 equals 9. There's my y-intercept. Okay? Alright, so I've got a y-intercept, 0, 9, or y equals 9. Alright? Now let's again take a look at what are the zeros, what are the x-intercepts, okay? If this equals 0, if f of x equals 0, either this is 0 or this is 0, okay? If 2x plus 1 equals 0, I'll subtract 1 minus 1. 2x equals 1, divide by 2, that x equals 1/2. That's one of my zeros, okay? Alright? Notice the multiplicity. That's how many times you have a 0. I only have 1 0 at that value, at that 1/2. Okay, 2 times 1/2 is 1, and, oops, that should be negative 1. I'm sorry. That's negative 1/2. Okay? That was negative 1. So I only have the multiplicity of this 0 is negative 1/2, and it's of negative 1/2 is 1, which means it's odd. Okay, which means that 0, the line will pass through the x-axis because it's an odd multiplicity. X minus 3 here, this 0. What would make this 0? 3 minus 3 is 0. But the multiplicity, there's two of these. It's x minus 3 times x minus 3. Okay, so there's two of those, right? There's x minus 3 times x minus 3. So the 0, 3 has the multiplicity of 2. Multiplicity of 2. So that means it does not, when your multiplicity is even, it's not going to go through like so. It's going to come and maybe approach, it's going to, not maybe, it will, it's just going to approach your touch, okay? There's an example. Now that might not be how it shapes out, but that's what it means. It doesn't cross through the x-axis, okay? Okay? So one thing you need to do when you analyze this graph is, we're going to go ahead and take this again, and we'll multiply it out. I'm going to rewrite this. 2x plus 1 times, be able to, multiply this out, x minus 3 squared. That'll be 2x plus 1 times, this x minus 3 squared, remember that's x squared, and my middle term will be 2 times negative 3 times x, that's minus 6x, and this negative 3 squared is plus 9. Okay? And this time I'm going to do a distributive property technique as far as multiplying. 1 times this is, and I'm just going to stick to my old way, but anyway, I'm just going to move this down here. 2x plus 1 is 9, negative 6x, x squared. Now I go over here, 2x times 9 is 18x, that's positive. 2x times negative 6x is negative 12x squared. 2x times x is 2x cubed. And I look at my columns, that's a plus 9. So this is what I'm multiplying right here though, folks, this right here. Okay, just this, I just moved this down here, alright, so 2x plus 1, so 9, negative 6x, x squared, and so on. Alright, so I just add up my columns, 9, 18, that's plus, and negative 6, that's plus 12x plus 9. Here I've got negative 12 and plus 1 is minus 11x squared, and 2x cubed. and that checks with what my textbook says, so I did it right. Okay? What's my leading term? Here's my leading term. Is 2x cubed. That's going to dictate the behavior of this graph. What's x cubed look like? Basically like so. Okay? But we've got all this other gook, so it's probably going to look more like it's going to have a little hump to it. Okay? Alright, so let's go graph. We said we had zeros at -1/2 and 3, but remember 3 had the multiplicity of 2. We had 2 roots of 3, so that will not, when we hit 3, it won't go through the x-axis, it'll just touch. So -1/2, here's 1, and here's -1/2, so I've got a 0 here. Here's 1, 2, 3. So remember, my graph is going to look something like this, okay? So we're going to go through at -1/2. It needs to go through, okay? And also we have a y-intercept where? We said we had a y-intercept up here at 9, okay? So let's just pretend. I'll make my scale here where this is, just so you can see, here's -1/2. Here's, let's say this is 10, and here's 9. So just for the sake of this, here's my 9, okay? It's not really to great scale. But I'm coming up, I hit 1/2. Here's 9, okay, and somehow it's going to come down around and it's going to hit 3 and just touch and go on up, okay, all right. So the textbook gave you a little different version of this. It's not really to scale, but notice how this scale here is 50, 25, so there's your 9, here's -2, there's your 1/2, so it hits 1/2. But notice how this scale, that's 20, represents 25. So it's a little smoother, and it comes over and just touches -3 and comes on up. Okay? So that's the type of thing you need to be able to graph. Okay? I can give you a real quickie one here, just as far as graphing. If you had something like x minus, or x plus, let's say x plus 3 cubed times x minus 2 squared, this 0 would be -3 with a multiplicity of 3, which is odd, crossing the x-axis. This 0 is 2 with the even multiplicity of 2, which will just touch. X to the third, and this will be x squared. My leading term will have an x to the 5th, which is going to be kind of like x cubed. It's going to have some kind of general shape like so, but we're going to have some more turning points. Remember our turning points. So, you can also figure out y-intercepts by plugging in 0 here, and 3 cubed is 27, and -2 squared is, if I plug in 0, it's is 4, so 27 times 4 is 100 and something, okay? So it's going to be, y-intercept would be 27 times 4, which is 28, 108. Okay, so 108 is my y-intercept, so here's 108, different scale. I've got -3, and I've got 2 as my zeros, okay? So, at -3, I'm going to go through, and at 2, I'm just going to touch. And remember, the general shape of an odd function is kind of like the cubic, where it's kind of go like this. So here I'm going to come up, -3, hit my y-intercept of 108, I think it was. Come on down and just touch and kind of go back up. So here's a 5th degree polynomial, okay, with only 2 zeros. And I have only 2 turning points, okay? All right, so remember, you can have as much as, if a 5th degree polynomial can have as much as 4 turning points, but it doesn't have to. Anyway, there's how I can kind of graph y-intercept and my zeros. Odd, odd number of multiplicity where I give the 0 3 times. When it's odd, you cross through. When it's even, you just touch. And there's a way we can kind of graph. We could factor this out and get the whole polynomial if we needed to. Okay, 10 minutes, time to go. I'll see you guys tomorrow.